We'll now turn to Chapter 10, which is one of two chapters on the binomial option pricing model. Chapter 10 will have 7 modules, the first of which will be some examples of option pricing on non-dividend stock using a single period in our binomial model. So we'll do a few examples, then we'll start building the math around these examples. So it's important to remember that a forward contract did not need to be priced by the markets separate and apart from stock. Once the market prices common stock, automatically it is pricing the value of forward contracts on that common stock. And the reason is that forwards can be replicated, that we don't actually need the market to introduce a forward contract because we can replicate a forward contract on a stock by creating a portfolio made up of going long the stock and then financing that position by shorting a T-bill. And we saw that from an earlier chapter, which is outside the scope of this exam, but it was on the earlier exam on this book, and that forward contracts are replicated by long positions in the underlying with a short T-bill position to finance the purchase. So we don't need a separate pricing of forward contracts. As an example, if we can create a long 3-month forward on gold by buying gold in the spot market, shorting T-bills, and in 3 months cover the short. So the cost in 3 months of gold will in fact be nothing more than the financing cost. So this replication idea works with gold because gold is what is sometimes referred to as an investment asset. Namely, it's an asset that many investors hold in inventory for accumulation or investment purposes. The reason it's important is that in order to replicate a forward contract or to arbitrage a mispricing in the forward market will often require us to be able to short the underlying asset. If the underlying asset is not an investment asset, for example, it might be corn, it's very hard to short corn because most corn is held in inventory for consumption purposes. There aren't investors holding corn that you could borrow and sell in the market as a short position. So these arguments work as long as we have an underlying asset that in fact can be shorted. And gold is an example of one. And when that is the case, the forward price is just the risk-free accumulation of the cost of gold. So as long as we have an underlying asset which allows us to short, and that will enforce this pricing, the forward price is nothing more than the risk-free accumulation of the purchase cost. And you can see I have a typo here. I was assuming that the cost of gold was $8.50 per ounce. If the asset pays dividends or requires certain costs to be incurred to hold the position, then in fact the financing cost will be adjusted. The remarkable thing about option pricing is that options, although much more complicated than forwards, are also assets that can be replicated. And again, just like a forward contract, an option can be replicated by a portfolio that only uses the asset, the underlying asset, and a T-bill position. Just like forward pricing, if you can replicate an option, the price of the replicating portfolio must be the price of the option. So replication determines the price of options. But there is a difference between forwards and options when you replicate, and that is the forward portfolio, the replication portfolio, was purchased at time zero and held constant until maturity. In option pricing, it turns out that the replicating portfolio has to be rebalanced. And all of the option pricing that we're going to investigate, we will see the rebalancing between the stock and the T-bills as you move through time. A binomial option pricing model enables us to determine the price of the option because it simplifies the creation of this replicating portfolio. This pricing model assumes that the price of the underlying asset, for example, a common stock, follows a binomial distribution. What does that mean? It means that if I know the stock price today, the stock price in the next period can be higher or lower than that price. Simple binomial, and then that repeats in each subsequent period. This model was introduced in a paper by Cox, Ross, and Rubenstein, which is quoted in the book.